Well, welcome to lesson 9.5 on dilations. And dilations are a type of transformation that is not an isometry, okay? So our dilations are actually going to be taking a pre-image and either blowing it up bigger or reducing it to be smaller. So we're going to have a center about our dilation. We're going to call that point C for center. And we're also going to have a scale factor. They're going to call that N. Now the scale factor, when it's bigger than 1, then we will have an enlargement. And when it is less than 1, we will have a reduction. Okay? The image of the center is itself. And for any other point that we have, N is going to be the ratio, the scale factor. To find the scale factor, what you're going to do is you're going to take any image side and divide it by any pre-image side, and that will give you your scale factor. Okay, so the image of a dilation is similar to its pre-image. So these two are not congruent figures. That's why it's not an isometry, but they are similar figures, which means that all of the angles are congruent, but the side lengths are proportional. You can show that the scale factor of a dilation has the same value as the scale factor of the similar figures with the image length in the numerator. So keep that in mind. We want the image length in the numerator. I should highlight that for you. Always keep that image length in the top. Okay, image length in the numerator. See if I can get that straight. There you go. Here is an example down here. The dilation is an enlargement, so the image has the primes on it and it's bigger than the original pre-image. So we know its scale factor is bigger than 1. So if the scale factor is between 0 and 1, then we know it is a reduction. Okay, so here's an example here of a reduction. So how do we find the scale factor? So here's an example of triangle XTR and triangle X prime T prime R prime. So the image is bigger than the original, so we know it's an enlargement. Okay, on this one, we can determine that that is an enlargement because the image is bigger than the pre-image. And the question then says, what is the scale factor of the dilation? Well, we know that this side, XT, is 4. And it looks like the entire side is the sum of 4 plus 8, which is 12. So we're going to take 12 divided by 4. Remember, the image is on top, and that gives us a scale factor of 3. When this number is bigger than 1, it is an enlargement. Okay? When it's smaller than 1, it's a reduction. Here's one for you to try. See if you can figure this out. Is it an enlargement or a dilation? So the blue one right here on the inside is the image. The black one is the pre-image. So tell whether or not it's an enlargement or a reduction, and then find the scale factor. Alrighty, this one obviously is a reduction. Okay, the blue one's smaller than the black one. And to be able to find the scale factor, you're going to put the image on top. So just take any coordinate. If you wanted to take, let's say, M and M prime. If you take the x-coordinate of M prime, it's -1. If you take the x-coordinate of M, it's -2. So we put the image one on top, 1 over 2. So we're going to have a scale factor of 1/2. So every single one of the coordinates, x and y, for any of these 8 coordinates will give you the same ratio of 1 to 2. And that is your scale factor. Okay, so this paragraph basically tells you how to find that scale factor and use that to write a rule. So we're going to go ahead and do a problem that shows that. Finding a dilation image. What are the images of the vertices of triangle PZG for a dilation with a center at the origin and a scale factor of 2 and graph the image? Well, first of all, what we want to do is to go ahead and write our rule. Okay, since the scale factor is 2, every single point we're going to multiply by 2, each of those coordinates. So let's identify the coordinates of P, G, and Z. Well, P is 2, 0, Z is negative 3, 1, and G is 0, 2. So doubling each of those, we get our new image points. And then the third thing we need to do is to go ahead and graph that. And so here's a picture for you with it already graphed. I believe I put graph paper on yours, on your notes, so that you can go ahead and graph those together. Okay? Dilations and scale factors help you to understand real-world enlargements and reductions, kind of like what you might see through a microscope or on your computer screen. So here's a biology example. This is actually a blown up or an enlarged image of an apple seed from your textbook. And it says a magnifying glass shows you an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows an apple seed under this magnifying glass. What's the actual length of the apple seed? Well, here's the formula that you're going to need to use to find these. So again, I'm going to go ahead and highlight this for you. This is going to be an important formula for you to come back to when you do your worksheet tomorrow. So the image length is equal to the scale factor times the actual length, and that's the formula that we're going to use. Okay? So the image length is 1.75 inches. This is the image after magnification. We know that it's 7 times what the actual length is. Okay? So if we wanted to find the actual length, then we're going to go ahead and divide both sides by 7. Okay? So we get P equals 0.25, so the actual length of the apple seed is 1/4 of an inch. Here's one for you to try. Go ahead and pause the video. I put the formula for you right there. Go ahead and plug in what you know and solve for what you don't know. Alrighty, hope you gave that a try. So this one says the height of a document on your computer screen is 20.4 centimeters. When you change the zoom setting from 100 to 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. So we know the scale factor is 0.25. What is the height of the new image? So we're looking for that new image length, and so that's what we're looking to solve for the image length, because we're looking for the new image, and the actual was 20.4 and it's being reduced, so we end up with 5.1 centimeters. Alright, here's your lesson check. Go ahead and work through each of these and bring your answers to class. We'll see you next time.